Okay, thank you very much. Greetings from Indiana in the USA in the Midwest. My name is Steve Peck, and I am the operations manager, or more specifically, the service manager at the Global NOC. Here's a picture of our service desk just to kind of give you a visual idea what things look like in there. And I'll just talk a little bit about our organization as a whole. The Global NOC is its own internal operation is within Indiana University. So we are all Indiana University employees, but we work on lots of different networks for lots of different people. We are centralized. We have a centralized operation in Indiana, which is, again, in the Midwest. We have two primary locations that are about 50 miles apart down the road. These are two of the main core campuses for Indiana University in Bloomington and in Indianapolis. I am in Indianapolis, just for a point of reference. And we do have a few staff that work remotely from Vancouver or New York or a few places like that, but that's pretty much to a minimum. And services that we offer, service desk, I'll talk a little bit more about these in detail in just a moment, but the service desk, the front end to the whole operation, network engineering. We do network software and tools, a lot of in-house development there. Do systems administration. We've also done network planning and consultation to a number of people. We've started to get into some research and development projects, and also now we have a new project management group that we've been able to leverage. As for the NOC structure, we are a 24/7 by 365 operation. The service desk is manned physically by a number of technicians 24/7 by 365. And engineering is primarily day shift work, but we do have on-calls for a number of different network relationships, et cetera. So there's always engineering support available to us 24/7. So the service desk, the group that I specifically manage, is the front end, and this ranges from call center activity to some pretty detailed, sophisticated network problem and cause and effect analysis. Our folks are not network engineers in the service desk, but they're very network knowledgeable technicians who have to be able to work across all the different networks that we support. Just as a frame of reference, we have 18 different network contracts or support arrangements with different entities, and that translates down into, say, 26 unique different network arrangements that we support individually. So, for example, we are the NOC for Internet2. For my staff, that means front-ending the IP network, the Layer 1 network, their ION service, and then their commodity peering service. All four of those are unique. We treat them as unique networks because they all have their own user base and their own needs. So there's a lot of different networks going on there. And so for the service desk to be staffed up, we have about 25 people in the service desk alone. And we have also Tier 2 engineering. This is just the day-to-day engineering and installation. So most of the stuff that the service desk passes to engineering goes straight to this group here. They also do a lot of installations across the U.S. And there's 17 people in that group. And then we have Tier 3 engineering and network planning. These are experts who are primarily assigned to different networks, and they are also assist in, like I said, network planning and architecture and working more directly with the network administration as well being an escalation point for Tier 2 engineering. We have a systems and software support group. There's 20 people in there. This is from mid-level developers to experts. We have a new project management team, which has about 5 certified professionals, and it all comes down to probably, I don't have an exact count, but 85 to 90 people employed at the Global NOC. Our types of users, well, since we are Indiana University employees, we support Indiana University, so it's staff and students. And then primarily the vast majority of our work is research and education networks. So I'll kind of list through those here in a moment. And something new here is that we support actually one of the departments in the U.S. government, NOAA, N-O-A-A, which stands for the National Oceanic Atmospheric Administration. They have a research network that they've contracted with us to support, and that's been very interesting and an exciting project, except for all the paperwork you got to go through to get clearance to work on projects, as you can imagine with things for the government. And then we've actually started working with some commercial partners on research developed projects. For example, we're developing or starting up an open flow lab, which is being sponsored by HP. User agreements, well, generally in the U.S., and particularly the networks that we support, there are no specific SLAs, no money being passed back if certain thresholds aren't being met, etc. But we do provide operational goals that we adhere to very strictly. And for example, that incident response, and then within the networks themselves, they have their own goals that they provide. So it's kind of like having an SLA without being on the hook. So we strive for that, very diligently. As for keeping track of users, we have an extensive network database, which has a lot of information about keeping track of the users, and then our ticketing system, of course. And we communicate through our users through traditional methods, such as, as many people are talking about, ticket updates being auto-generated from the ticketing system, and, the more traditional email, listservs, all that kind of stuff. We've developed a new notification tool that finally now is going to be allowing us to give targeted notifications instead of broadcast notifications, which is a really good thing. So I'm going to run through this pretty quickly here. The national networks that we support are Internet2 and National Lambda Rail. N-Wave is the name of the NOAA network that I just spoke of, and Future Grid is a testbed network associated with the TerraGrid project. Internationally, we support Transpac, and now it's Transpac 3. We've been doing this for over 10 years. That's connectivity from the U.S. to the Asian Pacific area, APAN. And now we have a new contract which we call ACE, America Connects to Europe. It's kind of the same thing, but it's over to Europe, and we are working on bringing that network up, which will probably be more like in the April to middle of the year time frame. We've started supporting some regional networks. The MAX, I don't know if you may be familiar with that, but that's a regional optical network in the United States, the Mid-Atlantic Crossroads in the Washington, D.C. area. And then we have after-hour support for the Connecticut Education Network. So we're supporting another state's network after hours. We have support these aggregation points, ManLAN in New York City, AMPATH, which is an international exchange point in Miami, primarily focused towards Latin America and South America, and the CIC Omnipop, which is a bunch of universities in the Chicago area, a couple of states area like that. And then a number of Indiana-based networks, of course, Indiana University. iLight is our state network here in the state of Indiana, a fiber network connecting higher ed institutions. Indiana Gigapop is the the Gigapop that we use to connect out to all sorts of different things. And IP Grid is a fiber network that runs to Chicago for research projects. Then there's a couple of projects. We're involved with the Genie project, the REN-ISAC, which is a cybersecurity effort here in the United States. And then we do support, my group actually front ends the Open Science Grid project. So that's not networks, but it's grid computing. As for infrastructure deployed, we've kind of done it all, and this is just real general. We've done fiber, obviously. That's an example of that is in the iLight network in the state of Indiana. We've layer 1, 2, and 3 networking devices. A lot of times in network upgrades or network build-outs on the contracts we've had, we have installation crews that go around and install gear everywhere, and then of course monitoring and measurement devices. Okay, for tools, I could talk here for a long time, but I'm going to be very general. We use footprints for our ticketing system, manufactured by a company of Numara. Right now we do over 15,000 tickets a year in support of all these different networks. We have a homegrown integrated network management system centered around a network information database, which provides network modeling and documenting various aspects of the supported networks, etc. It includes configuration information and drives configuration of other network measurement systems, management systems, and monitoring systems. So the database is kind of the central piece for everything that we do, and it pushes out in lots of different directions. As for monitoring, we use Nagios as the core. There's multiple instances of Nagios across the different networks. And we in-house developed something that my staff uses extensively. It's called AlertMon. It's an aggregator of all the different alarms that come up through Nagios into a web-based portal there where people, the latest alarm comes in. It comes in red. You got to acknowledge it. You got to start working on the problem, the ticket, creating a ticket, et cetera, like that. So that's something that helps us from having to work through multiple different Nagios instances. As you can imagine, that would be kind of time-consuming and a problem. Then we have developed SNAP, which is an SMP data collector. And I've got a few screenshots here of a couple of these things. The Global NOC Atlas and Worldview. These are 2D and 3D geographical visualizations of network usage data. Sherpa is an interactive, dynamic, user-controlled circuit configuration tool. Can provision VLANs. And Llama is a DWDM system measurement tool that reports back on light levels and errors, etc. And as I said, the vast majority, except for Nagios and Footprints, these have all been developed in-house, and we also offer the tool set as a managed software service. We have a couple of regional networks in the U.S. who have deployed our tool set. And there's a URL on our web pages of a more detailed listing of these particular tools and a few more that I didn't quite go into. Did talk a little bit about the integration. So the database populates our monitoring tools. The database also provides hooks into AlertMon, the alarm aggregator. It is integrated with our ticketing system. It provides field population in certain areas, so you can have affected fields and be able to have all the network devices for a particular network listed in there. We also have a new version of our customer notification tool. So the database is integrated with that, and also it's pretty much kind of run in conjunction with the ticketing system. And our systems engineering group is now working on a provisioning tool that will be able to be something that they can use the same tool for provisioning across multiple different networks. That's not quite done yet. Here's, if you can see that, this is just a kind of a screenshot of the database. This is one of the POPs in the U.S. It has a lot of, the POP information on the top, circuit information, etc. On the bottom, over on the right, you can, there's a schematic of the POP on the top, and then actually pictures. Every time one of our engineers goes out to the field, we take pictures and upload them to the database. So there's always hopefully a recent picture of what things look like there. Here's a not very exciting picture of AlertMon. Like I said, when the alarms come in there, they come up in red. A really irritating electronic voice goes off in the service desk telling people that they've got a new alarm that they need to attend to, and so that's one of the main things that we use. This is the worldview visualization tool or display apparatus. That kind of just gives one screenshot of what that kind of representing for the state of Indiana. It's something that we've developed, and it's kind of more of a show and tell tool rather than a lot of specific network functionality or practicality from a NOC standpoint. Although we are using that technology to work on further enhancements for understanding cross-network relationships, etc. NOC communication. So pretty much the same as everybody else that's has reported so far. One thing that we've been able to utilize a bit is Cisco telepresence. We have support, we partners in some of the networks we support arrangements with the NOCs, and we've been able to meet using telepresence, which is a nice way of just doing video conference. And phone bridges, IM, listservs, forums, that's the basics. You know all that kind of stuff. And for documentation, we use a documentation management software called WebGUI. It is not the most popular software that we have in our NOC here. It has its limitations. It has a wiki within it. I have a meeting later today about its future, whether we're going to continue to utilize it. I mean, it is very functional, though. It does provide us with a place to store all our documentation. We have a lot of documentation. And, of course, it's pretty much your standard operating procedures, technical information, network detail, and, training material and how-tos. We have, over the years, developed some best practices documentation. We don't necessarily have that posted anywhere on our website, but we've been able to work up incident response, problem management, change management, ticket priority and severity, and even a circuit connection turn-up process. I've actually have participated and led a couple of sessions at network conferences on some of the best practices stuff. And that's basically it for me. Here's how you can contact the global NOC. I see I didn't put in the international digits there, which is shameful on my part. And questions or comments, and that's how you can get a hold of me. Any questions?
Okay, so questions, please. Yeah. Just one question, Steve. You said the staffing level of the service desk was 25 staff, and that was 24/7. What does that translate to a number of people on shift? What, 4, 3, more?
So we have a minimum that we have to adhere to 24/7. That's 3 people as an absolute minimum. Now, night shift, we like to run 4 or 5 people deep if we can. Weekends is usually 3 people. And then during the day shift, we have up to 9 or 10 people working. We have some technicians who are specifically assigned to an individual network. They're kind of our in-house service desk expert on a network. So they work pretty much, your standard 8 to 5 hours. So there's quite a few of them. But yeah, it's usually on an average about 4 or 5 people on a shift. And it's when you're covering so many different networks, you got to have that many people because of all of a sudden you have a lot of events, and so much of the networks that we support are interrelated. So you have an event on one network, and then you have a kind of a cascade effect where sometimes The craziest scenario is like a fiber outage in Florida where we have to create 9 to 10 different tickets when you have a fiber problem down in Florida. So it takes a few people to do all that. Anything else?
Questions?
Yeah. Does your network management tool support device configuration? So I found quite many similarities to the NMS of CERN, and I was just interested if you are also configuring devices through these big and complicated databases on the device.
Yes, there are cases where there is configuration being done through the NMS. I hate to not be able to speak too much more, but I'm not the systems engineering guy. I'm more of a support guy. So how that the more specifics of how that works, I really can't speak to, but we definitely do some of that. And if you're interested in more, I can get more information for you.
Okay, maybe we will have some contact later. Thank you.
Yes, you should have my email there. Please send me an email, and I'll be able to work on getting answer to your question and more if you like.
Okay, thank you very much.
I'm just wondering, Steve, you talk about homegrown tools and in-house developed tools. Those are available open source, or is there any plan to open source some of those tools, especially those nice visualization tools that you have?
Well, there are some that are available to all. What I would suggest is, oops, sorry about that. Going back to the URL on our website that has a list of the tools right here, and like I said, we do offer it as a managed software service. So there is a for the whole kit and caboodle or major pieces of it. It is something that we contract with you about. In the case of like a couple of regional networks, they've have had their own instance of our database, developed for them, and the monitoring and the self-populator of the monitoring tools, and some of the other integrated tools, ticketing, notification tool, etc. So a lot of that is all very involved, and if you want to do one, sometimes you need to have the other, so there's prerequisites.
Okay, thank you very much. Yeah, one more question there.
Are those in-house developed tools developed and maintained by those same 25 plus 17 people, or you have separate team for development of tools? And if there is a separate team, how big that is?
So actually, that's a good question. In our systems engineering team, there's actually 2 teams within that. I just didn't want to go into all the there's a systems administration team, and then there is a software development team within that. And I think they're about split evenly about the number of people, about 10 in each group. Each group has a manager, so that we do have a team that specifically works on the software development and debugging and working with us on any kind of issues that we may have.
Okay, so thank you very much again for your presentation, Steve. I really appreciate it.
Thank you all very much. It's been a pleasure.